ones here.
So today we're going to factor trinomials. They're called trinomials because they have how many terms? 3 terms. 1, 2, 3, that's a trinomial. It says with a equals 1. A is the number in front of the x squared. So you see how it's just 1x squared. It's not like 2x squared or 3x squared or 4x squared. So this is the kind that we can factor with this method. The method is to start by looking for the GFC. Is there a number that divides all 3 terms? What's that? No, because this one doesn't even have a number, right? Do all 3 terms have x? No. So there is no GFC, so we're going to move on. We're looking for the factors of the constant term that add to the coefficients of the middle term. We're looking for 2 numbers that multiply to make 12. And those same 2 numbers add to make 7. All right. If you have them, don't say them yet because this is actually kind of fun. This is the fun part of factoring, is finding the numbers, okay? So the 2 numbers that multiply to make 12 and add to make 3 are 3 and 4. I don't know if I was supposed to write that there or in the next box on the side. It doesn't really matter. 3 and 4. Those are the numbers. To write the factors, we're going to have parentheses like this. All right. The numbers that multiply to make 12 are 3 and 4, so they go here. 3 and 4. Over here, these are the numbers that make x squared. What times what gives me x squared? X times x. Good. And in this one, everything's positive, so that's easy. These are going to both be plus. So these are the factors, and that means that if I multiply x plus 3 times x plus 4, and I combine my like terms, it's going to end up being this. X squared plus 7x plus 12. Let's look at the next one. Starting by factoring out the greatest common factor, 3x squared minus 6x minus 45. Think to yourself, what number can I divide all 3 of those by? But don't say it out loud yet. What number can I divide all 3 of those?
3.
Robbie says, don't say it out loud yet. Did anybody get the same as Robbie? Anybody else get 3? Does it work? Yeah? It does, right? Yeah, we can divide them all by 3. So our greatest common factor is 3. And I'm going to factor it out of each term like this. And I get x squared plus 2x minus 15. All right, negatives make the whole thing a little bit more complicated, but it's not that bad. Okay. Do not say these out loud. You got to give people thinking time. You want 2 numbers that multiply to negative 15. And when you add those numbers, they add to 2. If I'm going to multiply to a negative number, is that a negative times a negative makes a negative?
That's a negative and a positive.
Right, a negative times a positive. So when I'm thinking of numbers that multiply to make negative 15, I have to consider negative times a positive. Or maybe it's the other way around. Positive times a negative, right? So notice that I just take my time thinking through this, all the different possibilities, so I can find the pair of numbers that adds to 2. If you notice which ones they are, see if your neighbor agrees. Okay, the 2 numbers that multiply to make negative 15 and add to make 2 are negative what?
Negative 3 and positive 5.
Negative 3 and positive 5. Let's see. Negative 3 and positive 5. They do multiply to make negative 15, and they do add to 2. So good job. You guys got that. All right, so to write the factors, I'm going to have these two pairs, but I also have that 3 there that I took out originally. That just goes down there. The minus 3 and the plus 5 will go here. And then what goes in front? X, right. All right. So, finding two numbers that multiply to make 2 and add to make 3. The only way to multiply to 2 is what times what? 1 times 2, right? And luckily those numbers do add to 3, so you should have x plus 1 and x plus 2. Who has a question on that one?
Can they go the other way around?
That's a great question. Yes, it can. Because multiplication is commutative, which means that you can move them around. It can be the first times the second or the second times the first, and that doesn't change anything. So that's very good. All right, next one had a common factor. What common factor did we have to take out? 2. Good. Now that 2, after you take it out, leave it on the outside so we don't forget about it. It's still there. All right, most people find this tricky because we had to multiply to positive 16. But we had to add to negative 10. So, we had to realize that we're multiplying what numbers together? What kinds of numbers? 2 negatives, right? A negative times a negative can make a positive, and then when we add them, it will make a negative. Some of you figured that out, and that's good, but if you didn't, it's okay, because now you know, right? So, for the 16, it could have been 1 times 16, 2 times 8, 4 times 4, but none of those added to a negative. So you had to think about the negative numbers. Negative 1 times negative 16, negative 2 times negative 8, and negative 4 times negative 4. And finally, you found these numbers here that add to negative 10. So now let's write out our answer. The 2 on the outside, make sure you still have that 2 and you didn't lose it. X minus 2 and x minus 8.
And these can also be flipped, right?
Absolutely, yep. So maybe you have 2 times x minus 8, x minus 2, and you're still good. Any questions? All right, last one was also tricky because there is no number in front of the x. It has to multiply to negative 20 and add to what number? Negative 1, yeah. So negative x is the same as negative 1x. So it's going to multiply to negative 20 and add, oh, that's too many d's, add to negative 1. Okay, raise your hand if you found those numbers. Multiply to negative 20 and add to negative 1. Only one person found them? Raise your hand if you found those numbers. 2 people found them. 3 people found them. All right, Daniela, what'd you find? It's okay. Maybe Sonia will help you out. What did she find? Not yet? It's okay. You're about to find them, right?
Yes.
All right, let's ask Anne. What did you find?
Negative 5 plus 1.
Let's check her answer. Negative 5 plus 4. Does that make negative 1? Yeah? And does it, do those numbers multiply to make negative 20? Okay. So it'd be x minus 5 times x plus 4. Multiplies to make negative 20 and adds to make negative 1. Those negatives can get so tricky. On the back, all these words are kind of repeated in the context of the problem. So let's just look at the problem together, okay? We're looking at the problem in the box. I see a couple people still on phones, so I'm asking you to put those away. Look up. Here we go. Here's my problem. It's different because now there's a number in front of the x squared. Looking to find the numbers that multiply to 2 and add to 5 is not going to help us in this case. We have to do something more complicated because there's a number in front of the x squared. So what we do is this. You take your first coefficient and your last term, 3 and 2, and you multiply those to get 6. You see I got 6 there? So that these two numbers multiply to make 6. And then I need to find two numbers that will multiply to 6 and add to 2. And they happen to also be 3 and 2, which is like the numbers I started with. It's not always going to be that. So you multiply these two numbers, and that is telling you what you have to multiply to. Multiply to 6. Still add to 5 your middle number, okay? And the numbers that multiply to 6 and add to 5 are 3 and 2. And you break up this 5x into 3x plus 2x. So take a look. The 3x squared comes down. The plus 2 comes down. The only thing that changes is instead of 5x, I have 3x plus 2x. So the 6 is how we found these numbers. We just used it to find these numbers, okay? No, it's a good question. All right. Only one thing changed. I broke up my 5x into two pieces. Now, I group into two binomials. So I added these parentheses here. And I factored a GCF out of each set. When I say look for twins, look at that line. What do you think I mean by the twins? What do you see, Brenda? In the parentheses it has x and also what? Yeah. So do you see how they're exactly the same? X plus 1 and x plus 1 in the parentheses? That's what I mean by twins, okay? In the parentheses, those are the twins. Now, in the last step, you take the part in the parentheses. That's one of your factors. And it's being multiplied by the parts outside, the 3x and the plus 2, and that's the other factor. It's a lot of steps. Each step by itself is not too hard, it's just a lot of steps. If you know that things take you a while when there are a lot of steps, you need to make sure you're giving this your full attention. We're going to do one together. Are you ready? First thing, is there any common factor between 2, 7, and 3? 2, 7, and 3. Sonia says no. Brenda says no. You guys agree? What's that? Did you say 1? Yeah, 1 is always going to be a common factor, but there's not much we can do with that. So thanks for pointing that out. I appreciate it. So we're not going to take out any GCF. So next thing I do is I multiply the first and the last. 2 times 3 is still going to give me what? 6. So I need two numbers that multiply to 6 and add to what? -7. Thanks for paying attention. Two numbers that multiply to 6 and add to -7. It's hard. It's hard to find these numbers. All right, so -6 and -1 add to -7 and multiply to 6. So that's good. Those numbers were -6 and -1. Space is an issue here, so try to write small, okay? All right, now we rewrite this. Bring down the 2x squared. Instead of writing -7x, we write -6x and -1x. That makes -7x, right? So we didn't change anything. We're just changing the way we write it. And then bring down the +3. Raise your hand if you have a question. Go ahead.
So the equation like stays the same, just like the part that like splits into those like two numbers.
That's really well stated, yes. Anybody else? The 6, this one right here? Okay, good question. Oh, or do you mean the first 6?
Yeah.
That one? So I multiplied the 2 times the 3, and that's where I got this 6 from. And that always is going to work in these problems that are these trinomials, okay? So after I got that 6, then I knew that I had to find the numbers that multiply to 6 and add to -7, and that was how I got these two numbers. Okay? All right. Now we group the first two. So you're going to put parentheses around the first two. When you put parentheses around the second two, make sure that negative stays with the 1. Okay? So there's a negative here, and that stays with the 1. Right now it looks like multiplication. Just because I don't want you to think that these two are being multiplied together, I'm just going to put a plus right here. It's really not essential to finishing the problem, but mathematically it's correct to put a plus right there, so you don't think you're multiplying. All right, GCF. The first two terms, what number can I divide 2 and 6 by?
3.
What number can I divide them by? It's okay. What's that? 2. Yes, I can divide them both by 2, and they both have x. So I am going to factor a 2x out of the first two. So 2x is on the outside. X minus, and those two cancel. So I just get 3 on the inside. Plus. All right, what number can I divide -1 and 3 by? Nothing really, right? Except for maybe 1. What about, do they both have x? Okay. This is the only case when we're factoring by grouping that you will factor out a 1 or a -1, because you have to factor something out. If the number in front of the x is negative, you're going to take a negative out. So I'm going to divide by -1. And normally we wouldn't bother with that, but when you're factoring by grouping, you have to take something out. So I'm going to factor out that -1. And that's going to give me x. And then 3 divided by -1 is what? -3. Thanks, Robbie. Okay, do I have twins? Yes, look inside the parentheses. You see them? X minus 3, x minus 3. So when you have those twins, that's one of your factors, x minus 3. And the other one comes from the outside. So x minus 3 is being multiplied by 2x and by -1. And this is my final answer. And I really struggle with space on these. Feel free to grab some paper if you need extra paper. What can I factor out in number 2? A 2, right? So I'm going to start by factoring out that 2. Oops. And I'll have 2 times 2x squared plus 5x plus 2. Okay, so now we multiply the first one and the last one. 2 times 2 is 4. So I need two numbers that multiply to 4. And add to what? I heard that. Who was that? Good job. Multiply to 4 and add to 5. Okay, so 4 could be 2 times 2, but that's not it. What's the other thing I can multiply to get 4? 1 times what? 1 times 4, yeah. And those do add to 5, so those are my numbers. And remember, I cannot just put them right in the factors. It doesn't work. It doesn't get you the right answer. So what I do want to do is break up my 5x in the middle. So I have 2 on the outside, 2x squared plus 1x plus 4x plus 2. And I'm recording this, so if you find that this procedure is too long to get in one session, you can also watch it at home. All right, you add the parentheses to each pair. So parentheses to this pair and parentheses to this pair. This 2 on the outside, all you're doing is bringing it down each step. That 1 on the outside doesn't do anything else in this problem, okay? All right, so I'm going to leave this 2 on the outside here. What can I factor out of 2x squared and 1x? Well, they don't both divide by 2, right? They both divide by what variable? X, good. So I'm going to factor the x out here. I know it looks tricky because I took out a 2 earlier and now I'm taking out an x. I know that. That's tricky. Plus, what can I factor out of 4x and 2? This time I can factor out the 2. So 2 times 2x plus 1. This guy, he just comes down each time. You don't do anything with him. He's going to come down again. Here's my 2. He just sits on the outside, doing nothing. All right, I have my twins, right? So your twins are going to be one of your factors, 2x plus 1. 2x plus 1 is being multiplied by x and by what else? 2, right? So times this x and this 2, and so x plus 2 goes here. Okay, so I'm going to eliminate 4 and 6 so we have time to really focus on 3 and 5. And I want you guys to do these 2 right now, and I'll come around and see what help you need. Here we go. So we're trying to find 2 numbers that multiply to 5 times 6. So they have to multiply to 30. And they have to add to the middle, which is 13. And I already showed you how you make a whole list of numbers that multiply to 30. And then if you have that list, you are able to find the ones that add to 13. We found 3 and 10. So I rewrite the problem as 5b squared plus 3b plus 10b plus 6. Now, if you wrote 10b plus 3b instead of 3b plus 10b, it's okay. Your steps will look different from mine, but our final answer will look the same. If you're looking for somebody who did it the other way and did it correctly, you can compare your work with Brenda's, because I know she's got it. All right. So I'm going to put parentheses on the first 2 and on the last 2, like that. They don't have a number that I can divide them both by, but I can divide them both by b. So for the first 2, I'm factoring out a b. All right, so I'm going to take that b on the outside, and I have 5b plus 3. The next 2, they don't both have b, but I can divide 10 and 6 both by what number? 2. So I'm going to divide by 2. And again, I have 5b plus 3. So I have twins. That's one of my factors. 5b plus 3. The other factor comes from the outsides. 5b plus 3 is being multiplied times b, and 5b plus 3 is being multiplied by 2.
The two bits, the square, is that what you use to get the 2 that divides 10 and 6?
Well, whatever delta math you're on, guys, because there was one from last class and there's a new one from today, okay?
What do you mean when it's class you?
Yeah, I mean, usually we have a homework for every class. Delta maths are easier, though, because then you know if you're doing it right or wrong. Okay, multiplying the first and the last. I need 2 numbers that multiply to 12. And add to the middle number, add to negative 13. All right. So Anne has suggested some numbers. I'm just going to remind you, if you're not sure how to find the numbers, we do know it's a negative times a negative because it has to add to a negative. So Anne suggested this one, negative 1 times negative 12. If that wasn't the answer, you might also consider negative 2 times negative 6, negative 3 times negative 4, but she did give us the right answer here. Negative 1 and negative 12 multiply to 12 and add to negative 13. All right, so you split up your middle term. Bring down the 3x squared. Instead of negative 13x, you can have a negative 1x and a negative 12x. And then bring down the plus 4. We put parentheses on the first 2 and on the last 2. The negative should stay with the 12 when you do that. The first 2 terms don't have a number you can divide them both by, but you can divide them both by what variable? X. Good. So taking the x on the outside, I have 3x minus 1. All right, the next 2, what could I divide negative 12 and 4 by? I could divide by 2 and I could divide by 4. Which one's a greater common factor? 4. And when your first term is negative, you're going to want to divide it by a negative number. So I'm going to divide by negative 4. So the negative 4 will go on the outside. And then I get 3x and minus 1. So notice dividing by negative 4 also gave me twins. If you were having trouble finding the twins, it was dividing by negative that helped you get it. Okay, last step. Your twin is one of your factors, 3x minus 1. The other factor comes from the outsides, x and minus 4.